Dear participant, welcome back in the ninth session on data visualization and interpretation. Today our speaker was Dr. Poonam, but due to some urgency, she is not available with us. So her session will take Dr. Prayas Sharma, and this is third session for Dr. Prayas Sharma, Department of Statistics, Baba Saheb Bhimrao Ambedkar University, Central University, Lucknow, from India. And the workshop is on biostatistics from basic to advanced techniques. So without any delay, I would like to welcome our resource person, Dr. Prayas Sharma, and welcome to all of you to in this session to join the meeting. Uh, Dear Professor, over to you. We should start the session without any delay. And I make co-host you.
Thank you,
Yes.
sir. Thank you. Thank you. I believe I'm the host now, and then uh, let me just share the slides so that I can start. Yeah, is it visible?
Sir, visible, but your voice pitch is very low.
Okay, is it fine now?
Yes, sir, it is fine.
I'm deliberately using the earphone today just to make
Okay.
my voice a little better because yesterday, so last time it was not
Yes, yes.
uh, up to the mark. I believe is this fine now?
Yeah, fine.
Okay, good, great. Thank you, thank you.
And also, dear participant, whenever
Hmm.
you have any kind of question during the session, you can unmute your mic, or either you can put your question in the chat box also. So everything is open. Discuss openly. Put your question. Clear your doubt. Thank you. Thank you, sir. Please carry on.
Thank you, Dr. Meher. Yeah, good evening, everyone, and good afternoon to the participants who are there in abroad. Uh, First of all, I believe the session today, the data visualization and interpretations, is a very, very interesting sessions. And to make it more interesting, I just wanted you to trek through one of the examples, perhaps which you have not seen. And I also believe that you must have not seen that this may also happen. And because of this situation, we may need of the graphical representations of the data, that may be the pie chart, graph chart, histogram, scatter plot, etc., etc. So I'll just give you a very, very interesting example where you will believe that that graphical representation is always necessary, even though you have the statistic in your hand, the mean, variance, correlation, etc., etc. But still, always you would be able and you would like to see the graphs of that data which is available to you to get a full idea about the data, their interpretation, and what does it would the data would like to tell you. The data would like to tell to the to the audience, to the people. You can see here the four graphs, right? And four graphs are having the different points, and then we have drawn a line of the best fit. You believe that line of the best fit is same to all the data points y1, y2, y3, y4, and correspondingly x1, x2, x3, and x4. Can you tell me that what is the mean? If suppose I ask you what is the mean of the data which is available on the graph x1, y1? Yeah, can you tell me? So before I start, one thing I would also like to tell you that the topic for today is very, very general, and all of you must have gone through to this topic earlier, maybe somewhere, during your courses, during any such kind of workshop or something like that. So better better thing is to discuss more, to get your clear doubts more, and then you may ask the questions for the same, rather than just going this lecture in a one-sided flow lectures, and then you can listen, and then perhaps you can not really solving your doubts here. So you can see there is the four scatter plots available: x1 y1, x2 y2, x3 y3, and x4 y4, and we have drawn the line of best fit. Can you tell me what is the mean of x1 y1? No. What could be the possible correlation between x1 and y1? We have discussed that day, believe that we have discussed the correlations, and I think I spent much time
Positive
over
correlation.
the, yeah, positive correlation, definitely, yes, right, absolutely. But what could be the correlation? Means, if you would like to tell the quantitative measure of that correlation, what do you believe? What could be approximately the correlation coefficient? Okay, fine. So I I'm not sure that whether you have read this statement which is written on the slides or not. But this is the four scatter plot, four different data points, four different data sets, in fact, right, which have the same mean, same variance, and same correlation coefficient between the x1 y1 or x2 y2, x3 y3, and x4 y. Isn't it surprising, right? You can see that these are the three different data plots, right? But their descriptive measures are same. That mean, variance, correlations are same. And therefore, even if you have the knowledge about the descriptive measures, right, you cannot be assured that what is the behavior of the data, right? What is the behavior of the data? Because in all the four scatter plots, you can easily see that the behavior of the data is quite different, right? So somewhere it might be in the along with mostly the straight line, somewhere it is maybe in the curvilinear, somewhere maybe it is in vertical nature, somewhere where it's more scattered into the as the data sets, right? But they have the you know they have the same mean, variance, and correlation coefficient. So that is one of the requirement why one should know, or why one should represent the data, using the graphical representations, right? So many a times, we starts with the graphical representation, and then we move towards the descriptive measures, and then inferential conclusions, etc., in statistics. But you know even if you have the descriptive measures, right, please understand, you need to represent the data on graph, right, to get the behavior of the data. this is the data set which we have plotted here on the last slide, right? So it will be first data set as XY, second data set, third data set, and fourth data sets, right? And this data set combinedly specifically called as ENSCOM's quoted data sets, right? So if you type somewhere in the Google and quoted data set, you will find this data set, and this is especially made to make you understand that this may happen, right? Okay. And this I have used the R to make you understand their correlations and their other characters in terms of the quantitative values, and as well as in terms of the graphical representations as well, right? So you will also see here, if you could able to see that the correlation between x1 y1 0.8164 something, right? Correlation between x2 y2 again 0.8162. Correlation between x3 and y3 8162. X4 and y4, yeah, 8162, right? Similarly, we will have the y1 and x1 and so on and so forth, because you know that there is a properties of the correlation that it's whether you calculate the correlation of xy or whether you calculate correlations of yx, it will give you the same way, right? Okay, the next another example in this continuation is the called data's dozen, right? So we call dinosaurs, it's a data source dozens. Why we call it the data source dozens? Because there are 12 scatter plots available, right? And interestingly, they all have the same descriptive measures, right? As I said earlier, and but they have the different behaviors when you plot it around, right? So we can have the 30 sets of XY data, and each sub data sets have the 5 statistics that is the same in each case, right? I'll just, you can see just this is the data, right? So first is away, and then you say circle, etc. This is actually the name of the shapes which you will get here after plotting the data. And you can see mean of this is the same, mean of y is the same, standard deviation of x, standard deviation of y, correlation, right? So this is almost the correlation is same. All of them are minus 0.06 and then varying into the third places of the decimals, whereas up to one places of the decimals, the mean and standard deviations are exactly similar, right? And if you plot this data, you will get this here, right? So now, even if I can give you the data set along with this mean, median, and mode, and I ask you that which kind of data is that, you will not be able to tell me that which kind of data is that and what does it represents over the graph, right? So therefore, whenever you have the data point data sets, please understand, plot the data, and then try to see what does it represents on the graph, right? Is that clear? Any
Yes.
question? Please feel free if you have any questions in this regard. Otherwise, we will just shift to the, the traditional discussions of the plotting the graph like pie chart, dim pie chart, histogram, etc., etc. So this was I was just trying to show this through this examples. Then what exactly or why exactly are we talking about the
Hello?
representations of the means the graphical representations of the
Hello?
data? Def
Fine. Oh.
yeah, yeah.
Okay.
Any question?
Okay. Okay. The ones that they are one form, Abi. Okay.
Lauren, is there any question?
Okay, I will see.
Do you have any
Okay.
question, please?
Okay. Oh yeah, no wala.
Sir, please carry on.
Yeah. So definitely the graphical representation is important to see the behaviors of the data, how does it varies, etc., etc. But along with that, certain times it may happen that exactly you are looking for understanding the data through the descriptive measures, but it won't be able to tell you the exact behavior of the data, exact shape of the data, or what exactly the data wants to tell you, right? So you could see that we had multiple images. Out of that, one was showing the dinosaur, right, and another one showing the star. So which kind of thoughts, which kind of information you would like to give, you know it's very important, and that would only be uh, only be able to present graphically to have an understanding of such kinds, right? So we'll now see the traditional method of data visualizations. One of the very important thing of presenting the data into the graphs is that the graphs are much more faster to give you the information, to give you the insights of the data, which you see the data itself or when you see the graphs of that data. So definitely the graphs of any of the data set would be much faster to give you the insights of the data, right? One thing. And that is why always we are interested to see the graphs over the raw statistics, right? So for example, we must have seen, or we would be seeing the matches for crickets, football, hockey, etc. And you see that always the data, always the statistic of any of the players, the total matches, etc., etc., that all is given in terms of the graphs, right? The different graphs, maybe sometimes histogram, the pie chart, etc., etc., but that all is presented in terms of the graph. Why? Because, and you will also see that these kinds of graphs are pop-ups on the screen for only a couple of seconds, maybe 5 seconds, 6 seconds, right? But in those 5 6 seconds, you have the insights of the data, insights about the performance of that player, performance of the team, and how exactly the overall match is going on, you know, on any particular day, right? So when you say the variable is a characteristics or in characteristics of an individual which varies, over the executions or over the period of time, right? That is called the variable. And the distribution of the variables tells us what values the variables takes and how often these values can be taken and different maybe, right? You know that variables can be either quantitative. So when we say the quantitative, it means it's a numerical values for which the all arithmetic operations such as addition, multiplication, averaging, standard deviation, etc., etc., can be find out, right? For example, how tall you are, what is your age, what is your cholesterol level, right, etc., etc. So this kind of question which always give you the response in the quantitative types of variables or quantitative data type. The another form of the data, form of the variables, may be the categoricals, right? So categoricals means the where the things are present into the category. For example, the maybe the number of fruits, not the number, but the category of the fruits, types of the fruits, right? So sometimes that falls into one of the several categories that can be uh, counted, right? Or proportions of the individual in each categories can also be taken out if the data is given in the category. So I said the examples are the types of fruits, right? Types of you know types of flats, 1 bhk, 2 bhk, 3 bhk, etc. Types of you know types of uh, uh, what we call blood group, right? A, B, A, B, O, etc. Right? So these are the variables which presents in the time. Now, how do you know that if the variables in front of you is categorical or the quantitative, right? Then you need to ask certain questions. What are the n individuals in the samples, right? Of size n. What is being recorded about these n individuals? And is the number quantitative or an statement, right? So if the number is quantitative, definitely it would be a quantitative measure. If the number is in categorical, definitely it is in categorical level, right? For example, we have the individuals in this sample, patient A, patient B up to patient G, right? And there are some disease which is being diagnosis, right? Diagnosed, and it is given in the table. And then the another variable which is also the age, right? So age, definitely you understand, is a quantitative measure, whereas the disease diagnosed is categorical. So for example, heart disease, stroke, lung cancer, etc. So these are the categories. Rather, in front of them, the last age is quantitative in nature. And you could understand that with a quantitative measure only you can add, subtract, find averages, etc., etc., not with the categorical values, right? Okay, ways, now different ways where we can present the chart, where we can present the data into form of the graphical way, right? So when the variables is category is given in the form of the category, the data in the graph can be ordered any way we want, maybe the alphabetically, maybe increasing values in the nature, maybe by year, by personal preferences, by any of the other preferences you want, right? So that's given here in front of in front of you on the slides. So if I say the bar graphs, then each each category is represented by a bar, whether never married, married, widowed, and divorced. The another is the pie chart, right? The slice must be represent the part of the whole, right? So that is also represent here the pie chart. Now may I ask you that which one is better, right? Which one is better? First thing, and second thing, which okay, first tell me that which one is better. Then probably I should ask the second one.
Bar graph, sir.
Bar graph. Okay. Why?
Because without putting any effort, the things are clear that if this bar is going means means it is very apparent from this rather in pie chart.
Okay. Okay. So I could understand that you are saying that without much effort we can
Effort,
prepare the
yes.
pie chart, right?
Yes.
And comparatively it's easy to be prepared. Whereas when you have to draw the pie chart, then you have to calculate the degree as well,
Area.
right?
Area as
Yeah.
well. Yes.
Yeah. So degree as well, and then probably the area as well to represent it. Fine. Fine.
But
That's
not in context of preparation, sir. But even if this data is visualized with by the person who is not aware of my work, then even for that person also it is easy to get the information from bar graph. I think so, sir.
Right. Right. Absolutely. Absolutely right. See, pie chart is basically when we want to compare the different things under the one umbrella, right? That's, for example, if you would like to see your monthly expenditure, right? And that monthly expenditure definitely on the different things, maybe on the groceries, on the outing, on the restaurant, on the student children fees, rent, etc., etc. So that data is quite well to represent in the form of the pie chart, because ultimately these are the part of the expenditures rather than presenting as a bar chart, bar graph. Bar graph are mostly useful when you are comparing the different categories, right? Different categories for maybe the fruits, or for maybe the types of blood groups, etc., etc., right? But when you are talking to different subparts of a part and you would like to compare, the best or the better possible way is the pie chart. Okay. The problem with the pie chart is also quite easy, quite uh, quite regular, that you will not be able to differentiate, right, if the two sections are almost similar. For example, if you see the widowed one in the pie chart and the divorced one, right? So the divorced one and the widow one is slightly differ from each other, right? So in that case, it's quite different. It's quite difficult, in fact, to have an idea that which one is having the more more number of counts as compared to the other one. Clear? Whereas when you see this same two widowed and divorced graph in the in the bar chart, you could easily identify that the divorced people are more than the widowed. Is that clear?
Yes.
Yeah.
Yes.
So yeah. So whenever you see that your data is in such a way that it can present you the values, the frequencies quite similar, then always try to prepare the bar chart, right? Rather than the pie chart. That's what I mean. So preparation, yeah, is quite easy, right? Perhaps you would be able to know this, and I'm not going into the preparation because I believe that preparation is quite similar, quite aware to you. If you don't know, we may discuss. Just let me know. Yeah. So yeah, we have seen these examples, the cause of the dates and the counts, the percentage of the top tens, and then percent of total deaths, right? So you can see here the counts, and then percentage of the total deaths would be 26%. So for each individual who died in United States in 2001, we recorded what was the cause of the death, and the table or the above table is given in the form of the summary information about that, right? So there is the count. You could see 7,00142. Perhaps these number of individuals have died for or because of the heart disease, right? And this is the maximum number of percentage people who died in the uh, population, in the total population, and out of those, the 37% died from heart disease, right? And if you would like to see that how much there is a percentage, total deaths in percentage, so that would be 29, and so forth, right? Now we can present this in terms of the bar graph, right? And when you present this in terms of the bar graph, you could also see, or you could also decide a comparative study, right? That right from the heart disease to the kidney disorders, and the another one, we are moving into the decreasing water, right? That also we can compare. Definitely you can ask for the question, where is the highest one, where is the lowest one, where is the second highest one, right? But that will give you the best comfort, I believe, in that case. And you could also see that, to understanding of the data, this bar chart would give you the better understanding as compared to pie chart if you prepare in this case, right? Okay. Now, if you see that if we can sort it out through the alphabetically, right, the same data, right, uh, because where we have not sorted out based on the numbers, based on the rank, maybe if we can sort it out alphabetically, then this is not as good as if we can sort it out through the rank, right? So we can have the maximum, we can have the minimum, and uh, we can also tell that in which directions, right, it's moving down. Clear? So that is the understanding, that is the importance. When you present the data graphically, if you can keep in mind such a smaller thing, then definitely your graphs will be much more beneficial, right, as well as much more informative. Okay, right. So in the same case, right, if we present the same data into the pie chart, where each slice represent a piece of one whole, and the slices of this slice depends on the percentage of the whole to any specific category, right? So you can see, definitely we can easily understand here that heart disease or the death due to heart disease is much more higher as compared to any other, right? Or we can also understand that the cancer is the second highest, the the stroke is the third highest, and so on and so forth. But definitely when you go some deeper sides, right, maybe Alzheimer's or maybe kidney disease, influenza, then there is slightly, to understand that which one is greater, which one is higher, which one is lower, is slightly challenging, slightly difficult as compared to the bar chart, right? And that's what we were discussing. So when to prepare the bar chart and when to prepare the pie chart, etc. Right? Okay. Whenever you prepare a pie chart, right, please make the label as well. Why the label? Because labels gives you the number of a specific percentage, a specific uh, number of deaths in this case, in this particular examples, right, which can be easily identifiable. What are the different causes and etc. Yeah. Fine. Is it fine? Any questions so far? Okay.
So
So
far, so
can you
good.
tell me that, yeah, what does this chart tell you? This chart is prepare, that is the horizontal bar graph, you may say. What does this represents? Can you tell me?
Um, it's telling us about maybe quality of life or poverty level before and after intervention, UNICEF intervention. And it's
Okay.
showing how, for different countries anyway.
45 countries. Okay.
For different countries,
45 countries. Okay.
for
Good.
different, Finland,
Good.
Sweden, Denmark, France, for different countries, how they responded after intervention.
Good. Good. Anything else? Definitely, you can respond to, where is the poverty highest, where is the lowest, right? And then probably if you can any idea about the country's demographic situations, economic situation, maybe you can correlate with this, right? That what why it is so, right? So child poverty before and after the government intervention is given by the UNICEF 1996. So the data is given by UNICEF, and you can see that in UK, you know, before taxes and the transformations are 30, and after that it's 10, right? So apart from this, you can also give you the means you can also tell this kind of information in terms of that United States has the highest rate of child poverty among developed nations, 22%, right? 22% of under 18, and government does the least through taxes and subsides to remedy the problem, the size of the orange bars and the percent difference between the orange and the blue bars, right? So this will be able to tell you. Okay. And could you transform this bar graph to fit in one pie chart or in two pie charts? Perhaps no, right? And that's why this kind of bar chart is having the more importance, right? Fine. Uh, Now earlier we were, if you could, you know, if you could see or if you could remember, earlier we were talking about the presentations or graphical representations of the categorical data, right? Now we would be talking about the graphical representations of the quantitative data, right? So when we have the data in hand, right, we know the nature of the data, and according to the nature of the data we have to decide that which kind of graphs are suitable for the presentations of the graphical presentations of the data, right? So far we have discussed that there for categorical data we have the two ways to represent the data. Both of them are to an extent similar, but even if you would like to make the differences, we have already discussed what are the main few main differences, and when we should probably avoid the pie chart and when we should prepare the pie chart, right? That's what we have discussed. So if we have the quantitative data, we can prepare the histogram or the stem and leaf plot, right? We can also prepare the line graph, right? And we'll see one by one that how does it represent and what are their advantages over the others. So when you say the histograms, right, these are the usually the summary graphs for single variable, and they are very useful to understand the patterns of the variability in the data. How does the data varies, maybe throughout the day, maybe throughout the years, maybe uh, between the years, between the several years, etc., right? So you can prepare the histogram and then you can compare that what is happening. Maybe you can plot a expenditure of your uh, family over the 12 months, right, or over years. So you will get a histogram in this way, which can be definitely a comparative between the uh, means amongst the expenditure of the different months, right? As well as it can also give you the condensed informations of the data, right? So uh, the data gives you, or probably they condense the data points, the data numbers, but it can summarize, it can condense the data into the form of the smaller form of the graph, which give you perhaps the similar information what the large amount of data can give you. One thing. Second thing is give you the information much more faster way than anything else. Clear? Second is the line graphs or the time plots. So you can use this line graph when there is a meaningful sequences like time, and and the points help to emphasize any changes over the time. You can see here the histogram available in front of you, right? Please make sure that in the histogram, the sizes of the graphs, clear? So if you present the data here in the case of histogram, one thing you may understand that the histogram is side by side, right? So if you can understand this, if you talk about this bar, okay, it's given that the height of this bars is 13, because 13 states had between 5% and 9.9%, right? Hispanic resistance. So this is the representations of the histogram of the number of states and the percent Hispanic. Okay. We could also see that first column represents all states with the Hispanic percent in their population between 0 to 4.99, and the height of the column shows how many states have a percentage in this range, right? Because you can see that on the y-axis we have the number of states. One thing is also very important whenever you are presenting any kind of graph is the scale, right? What scale one must use to make the graph more attractive, more clear, right, and more meaningful. So if you could, you can take this range maybe from here only 0 to 10. That distance can also be used to represent 0 to 50, right? But in that case, the graphs will not look like as beautiful as this is. And when I say as beautiful as this is, means as informative as this is as well, right? This is the steam and leaf plots. So that plots is divided into the two parts. One is called the steam and another one is called the leaves, right? That is also useful for the quantitative representations of the data, right? And what exactly we do to prepare this, we separate each observation into two parts, one called the steam, right, which is consisting of the uh, final digit, the rightmost digit, and the leaf, which is uh, a remaining final digit, right? And steams may have as digits as needed, but each leaf contains only a single digit, right? So you can write that into the vertical columns with the smallest value at the top and draw a vertical line at the right of the columns. Each leaf in the row to the right of it is stem in increasing order, but from the stem, right? So, for example, we have the stems. You can, you know, you can see here that the percentage is given. In 1%, first of all, we have sorted data. Why have we sorted the data? Because whenever you are trying to prepare the stem and leaf plots or stem and leaf something, then you have, it's quite easier to sort the data first, and then you can enter or you can use it. Otherwise, you have to search again and again, and then you have to draw the data. Right? So similarly, if you could see, we have 0 as a right, 0 as a stems, and then you can see here it's written 0, 0.7, 0.7, 0.9. So it is given 779. Is that clear? Yes, is that clear? Anyone? Any question? Similarly, let me just explain the another one. Similarly, if I write the 1 as a stem, then what will be the leaves? You can start from here: 2, 3, 4, 5, 5, 7, 9. Right? That's one is the choice that you have to write even if the digits are repeated. Yeah. Why? Because then you can be able to understand how many those points are available or how many total data points are available. Okay. One thing you have to understand, if you see this, the first graph is state percentage, and if you see the so if you see this stem and leaf plot and this data, which was the raw data initially, which one is better? Definitely this one. Why? It it does contains the large amount of data into this smaller part. One thing. Second thing, you could also understand the one may say the variability of the data, how variables the data is, right? If I ask you one question, I know you must have gone through earlier the mean, median, mode, skewness, cortices, etc. Can you tell me, if I draw this data stream and leaf plot which is present here, right? What will be your graph? Okay. One thing is also very important in terms of the condensing of the data, in terms of the representation of the data. After that, one thing is very, very important, that you could get the different measures from this stem and leaf plot very fast. For example, if I ask what is the range, right? So the maximum value is, the maximum value here for this plot is 25.3 maybe, right? And the smallest value is 0.7. So if you have to plot the data, you can easily plot that. If you have to find the range of those data, you can easily get this range of this data, right? So stem and leaf plot can be used to compare the two related distributions on back-to-back stem plots with common stem is useful, right? So you can have the common stems and then different leaves, and when you present the data in this form, you could able to understand the related distributions. As I asked, which kind of distribution it is, or whether it is a positively skewed data or negatively skewed data, or the data is symmetrical, right? So such all information can be useful and can be directly given by the stem and leaf plot to the desired people, right? One of the disadvantages is that it cannot be, very feasible when the data set is very, very large. Why? Because obviously you have to do this manually. You have to count this, how many are there, then how many would be kept into the, let's suppose, stream one, and how many of them can be treated as the leave one, right? So for large data set, this is not very, very useful. When the observed value have too many digits, right, you can trim the numbers before making a stream plot. When the plotting a moderate number of observations, you can also split the each sorry, you can also split the each stream. Now if you see here, I have just compared the stream plot versus the histogram. Which one do you think is better? So when I ask better, means definitely in terms of the information, or which one is giving you the sorry, fast information, as compared to the others. Yeah, someone has responded over the chat, histogram. Okay. Yeah, sorry. Okay, great. Right. Both are in terms of the information, both are similar, right? You can see here, if you see the stream and leaf plot, it's nothing but only the horizontal way of representing this histogram. Am I right? Right. If you can make it just vertical, you will see like this, right? And you can better understand that whether the information is given higher or whether it's lower. Fine. Okay. Next is interpreting the histograms. So when you describe the distribution of a quantitative variable, we have to look for the overall shape of the histogram rather than the spikes, or rather than the any individual bars, right? And we can describe the overall patterns of histogram by its shape, by its variability, means how much it's spreading over the limits, over the range of x or y, and then what could be the center, right? So you can see that there are histogram present, similar histograms. One is being categorized, one is being, you know, drawn by the smooth hand curve. Another one is by the specific lines, where we are adding the midpoints of one bar to the another bar, and then these lines are being drawn, right? So if you see this graph, the hand graph, the smooth hand graph, you will be able to understand that this representation, or the data, or the characteristics, whatever is being represented here, is quite 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 symmetrical in nature. Is that true? Yeah, quite symmetrical in this nature. Whereas when you see this graph, rather this lines connecting, right, you won't be able to understand that majorly it is forming a symmetrical distribution. That is the advantage of presenting the data into the histogram and then drawing a smooth curve, right? Okay. Just give me a minute. Let me just plug in my charger. Yeah. Good. So a distribution is symmetric. You know when it is called the symmetric? When the right hand side and the left hand sides are approximately a mirror image of each other. So it will be called as a, symmetrical one. So I believe while discussing the distributions that day, we have discussed this symmetrical, asymmetrical. Perhaps we have discussed the normal distribution, and that is the symmetrical one along with their properties, right? If it is not symmetric, that means it is asymmetric. Now, if it is asymmetric, then where is the skewedness? Means in which direction the skewedness present in terms of the data or further the distribution. So the distribution will be called as a skewed to right if the right hand side of the histograms extends much farther out than the left hand side, right? Or you may say that if the tails of the distributions looks like into the right hand side, right, then it is the rightly skewed distribution. If the tails of the distribution or the distribution extends much farther out than the right hand side, then it will be called as a negatively skewed distribution or the left skewed distributions, right? So you on the slides there are three graphs: one the symmetric distribution, one the skewed distribution. And this skewed distribution is which kind of skewed? Positively or the negatively? Can you tell me, anyone? This one, the second graph, the second histogram, in fact.
But only one histogram is visible.
No, I believe there is three histograms. Now there's two histograms. One is the symmetric one, and then below this there is skewed distribution. Yeah, is it?
Yes, now it
not
is visible, sir. Yes, now it is visible.
Okay, right. So I just wanted to know that which kind of skewedness is this? I have just
Negative?
explained you. I have just explained you the how to measure the skewedness. Skewed to the right if the right side of the histograms extend much farther out than the left hand side, right? Or the tails of the distribution or the tails of the graphs is towards the right hand side. Tails means, you understand, when it gets the narrow downs, the size of the bars it's decreasing, right? So if the size of the bars is being decreasing towards the right hand side, definitely it's rightly skewed. If it is towards negative side, then it is a negatively skewed distribution, right? Okay, great. Now the third graph is available on your screen. So practically, it's not very easy to get always the data either in symmetrical or positively skewed or the negatively skewed form. Rather, sometimes it can be a complex multi-model distributions, right? Where you could see that the bars are being presented into the different ways, right? So this is called the some complex models, right? And in this complex models, we have to decide later on that whether the distribution shown by such histogram is uh, is representing some of the practical phenomenon, some of the real phenomenon or not. If not, then you can trim this graph as well, trim from the both side or one side to get an idea about the distributions, and then you can work on it. Okay. Yeah. So outliers, when we represent the data further, we have discussed the outliers things when we were discussing about correlation and regression. But let us see with the lens of the graph, right? So when you have represented the histogram of any of the data set and look like in this way, right? So when it look like in this way, it means it is out out from certain patterns. So we started the pattern, you could see, from the age 8, right? Percent of state resident age, okay, percent of resident from 8 and then goes till 16. Whereas 5, which starts 5 and which starts of 18, are in not in the patterns, right? Right. So if you could find here, if you could see this graph, so the pattern is fairly symmetrical if you can only consider this the middle one, right? You know the meaning of symmetrical now. But if you include these two one, right, which is the Alaska and Florida, it is not the usual representation as compared to this symmetrical graph, right? It's unusual of the elderly in their population. So a large gap in the distribution is also, typical signs of the outliers. So if there is some gap and then it starts, please treat this as an outlier, and definitely, uh, you know, you can understand about the distributions. Yeah, fine. Okay. Now, how to create the histograms? So it's an iterative process. Try and try again, and then you can prepare some kind of good graphs. What win site should be used is definitely one of the important important uh, considerations, because when you present the data into the histogram, actually the area of the rectangle shows the importance of the categories. It's not only the y part or the x part, it's the area of the graph which shows the importance of those category. For example, you represented, so you can easily see that this one is higher, right? But this one is higher means the area of this over the graph is higher, is much more as compared to the other one, and that's why we say that it is higher. Okay. So not too many bins should be required, where 0 or 1 counts, not overly summarized that you loses all the information, not so detailed that it is so longer summary, right? Rule of the thumbs, you may say that it is, you can prepare the bins between 5 or 10, right, as per the requirement, right? And look at the distributions and refine your bins, right, that you can do. See here, frequency and then bit length. Again, there's a frequency and bit length, frequency and bit length, bit length and frequency, bit length, right? Which one do you think is better? Same data set is being prepared here, right? Same data set is being given, right? Which one do you think is the better one? Better representing the data, better giving you the information about the data? Anyone? Third one, yeah, very correct, Pooja. The third one is better as compared to the all others. Why? Because in terms of the information, what we see here in the terms of the graph, so it is well represented in terms of the, if you talk about the horizontal axis, even if it gives you the good understanding when you consider it as the vertical one. So you can also imagine that it gives you the some kind of symmetrical feelings of the data sets, right? Good. So the inner one two summarized and this one is not summarized. So perhaps the third one or the fourth one is summarized, and out of this, the third one is the better one, as said by both of you. Thank you. Your data are the way that are, so do not try to force them into a particular shape, right? So obviously, you sometimes it happens that you mislead the data or present the data because of your benefits into certain ways, but please do not do that because it will mislead you in terms of the information. It is, so it's a common misconception that if you have a large enough data set, the data will eventually turn out the nice and symmetrical form. uh, it happens usually, but definitely then which kind of data you have, right? So that is why many a times we have the nature or characteristics of the data as a skewed one, not symmetrical one, right? So you can represent the data and have an idea about this. Next is the line graph, right? So or time plot also we call it sometimes. So is this time plot or line graph always goes on the horizontal towards the x-axis, and we describe time series by looking for an overall pattern and for syncing deviations from that patterns in a time series way. In this kind of graph, our main objective is not to see the specific values, rather than to get a trend over the number of years, over the several years. So a trend is what is a rise or fall, right, over a larger period of the time, right? Again, in this one, we can also find out the seasonal and cyclical variations if there is any. So a pattern that represents itself on a regular interval of a time is seasonal variations. If it represents within a year, then it will be a seasonal variations, right? For example, the retail price of fresh oranges over the time, if you present, and you can see the graph here, right? So the time plot shows that the regular patterns of yearly variations, and these are the seasonal variations in fresh orange pricing, most likely due to similar seasonal variations what I said earlier in the productions of the fresh oranges. So whenever there is a productions of the fresh oranges, uh, the retail prices would be different as compared to the another one. But if you would like to see the overall prices of the oranges, you could see if you can draw a trend, right? Or if you can see the pattern, you will find that there is a patterns of upwards increasing directions, right? So it could simply be reflecting on inflation trends or more fundamental changes in the industry as well with respect to this graph, right? A simple time plot can also be presented with respect to the influenza epidemic 1918. The data is being recorded week wise, and then how many cases are there in the weeks, and then how many deaths are there in the weeks. And you could see surprisingly that the both the plot, you know, both the plots goes along, right? So if you could see here, you will find that over the time, the number of flu diagnosis closely resembles that for the number of deaths from the flu, right? And this may further tell you that approximately 8 to 10% of the people diagnosed that are here died shortly afterwards from complications of the flu. Clear? Right? We may also get certain other informations from this graph. Then what was the distribution of these graphs, right? And you know, how does it goes as the number of weeks increases or as the time increases. And even if you can have an idea about those time period, then you can relate multiple things and draw certain conclusion based, right? Okay, so there's the scale matters. I was saying that earlier, that whenever you are going to prepare the graph, right, please understand that what scale suits you, right? And perhaps the same we have discussed when we have prepared the histogram of 5 types using the same data sets, right? And it's good that you responded the right answer, which one was the good graph, good histogram out of those 5. Here, which one do you think is the better one? You can see that it's written, a picture is worth more 1,000 words, and that's definitely right. If you have to explain the graph, any one of the graph, probably you have to write certain statements to make people understand what exactly is going on. But when you present this in terms of the graph, it is uh, self uh, you know interpretable, right? Self uh, understandable, so people can easily be understand. So yeah, by the way, which graph is better one here? Definitely, when I ask the better one, it's looks and also the information which you are presenting. Yeah, right. So the one on the 4, right? The one on the right hand side. Good, good, very good. Why? Because it starts with a 0. That is fine. The scale on the y-axis is quite good, right? The scale on the x-axis is also quite good, and we can see a easy pattern while seeing this graph, right? If you see the first one, you could see that there is slightly increasing in the pattern. Third one here on the cursor one, yeah, it's look like that it's moving in the 45-degree, right? But it's not exactly like that. So this one is the best representations of this situation as compared to the any other one. And how does it varies? It varies only with respect to the scales what we have chosen. And you know that when we are going to prepare any of the graph, we ourselves prepare the scales first and then we draw the graphs, right? Okay, great. There is a graph present on this see on this magazine, right? And it shows that kernels ranking over the times, right? And kernels tuition over the time. Can you tell me what is wrong into this? or why does it matters? Anyone? The picture is not clear. Okay, the picture is not clear. It's one of the matter, right, which we should forget here. The main thing is, you see the y-axis and the x-axis, right? The ranking graphs covers an 11 years periods and the tuition graph 35 years. Yet they are shown comparatively on the cover and without a horizontal time scales. On the cover, definitely there is no time scales, right? Ranking and tuitions have very different units, yet both graphs are placed on the same page without a vertical axis to show the units, right? Very interesting, we generally come across such kind of graphs on the cover page of the magazines, even in the newspapers, you know and we believe that whatever they want to show, whereas it is not exactly the truth, right? So the impressions of the recent sub group is that ranking graph actually shows that colonel's rank has improved from 15 to 16, right? But it never happens, but it's not true. So that is why the scale of the graphs are very, very important, that which is scale uh, is quite to graphs, you understand. Yeah, so these are few other summaries which I have taken from the mean calculation. So you know what is mean calculations, various calculations. Just to represent over the graph, I have taken these figures, right? On the first axis, on the first graph, in fact, you can see the distributions of women's heights appears coherent and symmetrical, right? And the mean is good numerical summary here. Whereas when you present this number of plants and heights in centimeters, right? You could see that the mean is here. The graph, I would say, this data set, and therefore the shape of the distribution is very, very widely irregular, right? And that's why you could see the mean here, yeah, not exactly in the middlemost, rather in the few things, few steps ahead. Okay, this is the another representations of the three different plants, which was here in this data set, right? It was saying that why is this irregular, right? So it's later on we see that it's at the three different plants, right? And let us represent into the three different colors, that's blue, pink and red. And then therefore we can see that they have the three different means. So 63.9 and symmetrical with respect to the presentations of the data. We were talking about the symmetrical and the through graph. So you could see one is the left skewed, third one is the rightly skewed. So wherever you see the tails of the distribution, that side will be called as a skewed one. Negative. If tails is going towards the right, it is right or positive, right? Okay. Yeah, we have discussed this outliers and this, so while I will not go into that. Okay. Yeah, the another form of presentations of this this data or the statistic is the box plot. So box plot is again I don't know whether you have discussed in the earlier classes or not, but that's a 5-point summary. 5-point summary because it gives you the 5 different measures about the data sets having in hand, right? So this the more and more important. Okay, is that fine now? Is that stable now? Is the voice is it stable? Yeah, thank you. Please do let me know whenever you have the not a clear voice or if you have any questions. You may also write in the chat box. No problem, right? I will respond to that. Yeah, so we can rather than presenting the whole data set, you see the data set here, how long it is from 1 to 25 rows, right? So you can represent the same data set in the form of the box plot. And box plot, I'll say certainly that will give you the much more information about the data set, about the distribution, right? Than this data set, right? Okay. So the high box plots give you the largest value, right? So you know in the distribution, minimum value, there is a kind of a graph, right? Which starts with this line. So this line is nothing but the first
Dr.
quartile.
Sir.
This line is the third. Yeah.
Sir, your voice is not stable, breaking.
Okay, just give me a moment. Let me just fix it up.
Disturbing voice.
Yeah, maybe this the earphone is moving around, and that's why probably this. Is it better, stable now?
Yeah, it's better now.
Great, thank you. Yeah. So the first line gives you the first quartile, the third one gives you the third quartile, and definitely the middle one will give you the second quartile or the median about the distribution. So whenever you represent this box plot, it gives you the overall information about the distribution, right? And as I said earlier, that it will give you the not only the information about the all of the distribution, all the data sets, rather it's give you the fast information as you if you see the data set or as if you plot the box plot, right? That's what the meaning is. Even you can compare the two box plot easily, very clearly, right? Rather when you would like to compare the two data sets, right? You see here of disease X and let's say the another disease multiple myeloma, right? And you could easily understand in terms of the skewedness, in terms of the variability, in terms of quartiles, in terms of happening the disease, in terms of the time of the disease, right? In terms of the years, in terms of the deaths, etc., etc. But if I give you the data set of these two diseases in front of you, you would not be able to tell me the things which you can directly see with the help of this box plot and clearly explain. right? Okay, if I ask you in these two box plot, which one is the skewed one or which one is the symmetric one? Can you tell me? Yeah,
Sir,
can you tell me?
skewed can be depicted, but where the right side or left side is not means clear. Skewed is because the line which is cutting the bar is symmetrically cutting or not cutting it. It box means.
Okay.
But where it is skewed, either left or right, horizontal, vertical thing is by this vertical thing is not clear.
Yeah,
Why?
actually in the what? Right,
Why
right.
you have given in the upper side of the slide skewed right and left. It is clear, sir.
Yeah, I understand. Yeah, very correctly, Mrs. So when I say this, when we present the box plot here, like in the horizontal and vertical way, right? So its upward direction is the right one. Why? Because it is increasing, and the downward side is the negative one because it is decreasing, right? So if you could see the upper part of the slides, we have presented in the horizontal part as well, right? Which can definitely give you the right understanding if you are having any confusion in terms of the vertical bars.
Okay, sir. Fine. Then we can clearly find out. Yes. Thank you.
Right now, if I ask you how much data are there in these two data sets, right, above the median, are you getting my question? Above the median, right? So if you see, I'll just explain it by myself. In the first one, the median is exactly the middle one. So the 25% of the upper side of the median and the lower side of the median, upward size is more, right? So then you can interpret into that way that how does it show significance on your data, results on your data, right? When you have this such box plots or any such figures, you may say. Okay, using this box plot, you can also able to get the outliers, right? While calculating the interquartile range. So we calculate the interquartile range and then we multiply with 1.5 to get the outlier. So anything which is beyond this limit will be treated as the outlier. So if it falls more than one first quartile or below the third quartile, then it will be a outlier. We can call it as outliers. You can see here, this is the data, this is the box plot. You could see the minimum point, the maximum point, right? And then we have found out the interquartile range. So any point which is above this interquartile range, you could see easily that we have drawn here. So any point which is above that range will be treated as the outliers, and then it would be suggested to remove the outliers into your further analysis. Otherwise, it will give you the wrong interpretations in terms of the in terms uh, in terms of the conclusion. What would you like to draw, right? So you could see that 25 has a value of 7.9 years, which is 3.55 years above the third quartile, and this is more than 3.22 years, 1.5 into interquartile range, and thus this 25 values would be, means having the 7.9, would be treated as the interquartile outliers. Clear? So this is very you may say the easy way to represent as well as to understand the outliers into your data sets. We can also represent the data in the form of the density, which is called the density curves. Generally, Such curves, we used to draw whenever we talk about the certain distributions, certain specific distributions, or whenever we would like to model the certain distributions, right? The behavior of the certain distributions, then we plot the density one, right? So density is, you may say, it's a kind of the freehand curve, right, which may be drawn over the histogram. You must have seen in the initial slides, or which may also drawn without having these kind of graphs, right? So we may plot this to get an idea about the certain distributions. Even if you plot this density, these are just the applications of the normal distribution. If you remember, we have seen that day. If you plot certain graphs, certain densities in this form, it means that, right, we are plotting this with respect to the normal distribution having the same mean as 15, but the different variance, in fact, right? And that would, you can see, for first one, the sigma is 2, for the fourth one, sigma is 4, and for the sixth one, sigma is 6. Can you tell me to which one I am calling the first, second, and third? Means where is the variation 6 and where is the variation 2? Yeah, anyone? I
The
hope.
blue one is 2, green is 4, and red 6. Blue curve is 2.
Yeah, good, right, exactly. The blue one is 2, and then 4, and then 6. So you could see that is showing the spreadness of the data, right? So if spreadness of the data is high, definitely the sigma is high, right? That's what the the meaning is. In the second graph, you could see that all the graphs are similar with respect to the variations. So sigma would be same, but their means are different because their starting point and ending points are different, and therefore their means are different. Clear? Okay. This we could have seen that day whenever we were discussing the normal distributions, that if we plot the density curves and if it does follows the symmetrical shape, right, usually we have the data set containing the 95%, 99.7 percentage, and then 68%. Yeah. So this might not be related to you discussing at this point of time, right? So that's all from my side. If you have any questions, you may ask, right? Or we can discuss over it. Or if you would like to add certain things, if you'd like to uh, add up to the content what we have discussed, please feel free. So I believe unless Dr. Chand would not invite you, you won't come to ask the questions.
Yes, sir, I am here. Dear participant, if you have any question, you can unmute your mic. Please put your query for further to clear your doubts. Sir, how we can actually through the presentation, we discuss everything. So there will be some challenge to use R software for the visualize of this type of the results. So can you please demonstrate some examples how by using the R programming and some commands so that they can plot this type of the examples which you present through the PPT. This will help to the participant.
Would you like, sure, should you like me to demo now or give you certain commands which can be used later
Certain
on?
commands with using R.
Right. Let's view the R file where there will be a certain commands using certain examples for preparing the bar charts and the pie charts, right? I'll send you that file. If you want me to represent now, just give me a moment. I can open and show you. Maybe at least one or two.
If you can present a few examples and also provide us the file.
Sure, sure. Just give me a moment. Just let me open the R. I'll do. So in R, we may create certain pie chart, histogram, bar chart, etc., based on any of the data, right? I'll just use, just let me give a moment. Is that visible? Is my screen visible?
No, sir, not yet.
Okay, okay. Just give me a moment. Do let me know whenever it is visible. I have shared, but maybe because of the speed of net, it might not be visible to you.
Yes, sir, it visible now.
Good, good. Thank you, thank you. So, yeah, let us see that with that day we have discussed a few things in the R. So, whenever you would like to enter any data into the R, we can use this combine command, right? And I'm just running it. I'll share this codes with you. So, this data is that. Later on, if you would like, if I'm interested into preparing the histogram, so there's a hist, HIST, and then data. This data means this data which we have already entered. Main means this is the above the histograms what we need to write. X lab means what you would like to write on x-axis, what you would like to write on y-axis. Do you want to use any colors? That's what is being. We have certain arguments. One of the arguments, then you have to supply the data, and then you have to do this. Okay, let me just run it. So there is a histogram present in front of you that you can prepare. right? Later on, you can create certain, data sets by yourself, as I have created here using the normal distribution. So R norm again is a function which have the different argument using mean and standard deviations. So there is a data, and then is a R, right? So you could see that we have the histograms with the 20 bins, and overall this follows the normal distributions. Why? Because we have created the data with the normal distributions, right? And I would also like to show one thing with respect to the statistics. This is the 1000, right? If I put it 10,000, you can see the same graph, right? Could you see that how well behaved this graph is now as I have increased the data, right? Similarly, the next example would be you could have this graph with a different density curves as well. So we could prepare the graph, and then we could also write the densities, and this density curve would definitely let you know that whether or approximately it follows certain distributions, if you are aware about the graph of the certain distributions in that. Clear? So this is the histogram. Any question? It's all about the writing the codes and just keep on running. Now let me just show you with the two data sets. So we have the data 1 and the data 2, and we have created both with the normal distribution with the standard deviation 50 and 6, sorry, with the standard deviation 10 and 15 respectively, with the mean 50 and 60 respectively, right? And let me just draw the histogram, right? So one of this histogram here, right? And for the second data, this histogram here. And the good part is that, let me just zoom it and you will be able to see it, right? We have prepared both the histograms here in the one plot, right? And this would be always very, very useful whenever you would like to compare the two data sets, right? And this is quite a new form of presenting the histograms, where you can easily get the comparisons of the two data sets. So this can also be presented using the R softwares, right? Apart
Any question,
from
please?
this, in the R, actually, we many a times, or in fact most of the times, we present this uh, uh, graphs using the ggplots, right? Because ggplots is, I think, the very, very extended version, and it's gives you the great understandings about the graph. Let me just show you the few examples of the pie chart as well, right? So conceptually, when we would like to create the pie charts, we have to first create the slice, right? So we can have the different slice and names. So perhaps we can give this slice and names, and we can create the basic pie chart, right? If you would again like to make certain colors, or you would like to calculate these slices by the computer or command itself, it will calculate by themselves, and then it can create a pie charts in front of you, right? So that's also you can create with the command pi. So pie is the command under which we have the different arguments, right? And different arguments can be run here in this way, right? For making it more beautiful, more approximately, let us use a package plotrix, right? So it was not installed. Let me just install using this install.packages command, get the library, right? And then you can prepare again with the same labels. So like you can see that there is a 3D plot, uh, uh, 3D pie chart of this given data sets, right? So we may present from basic to the advanced. We can make it more attractive. We can make it more informative. As whatever you want, you can do that. Clear? I would also just since I have opened, I would like to quickly show you the examples of that uh, uh, data source. Right? It's quite interesting. Let me just open it up. Yeah. Yeah, so for this data sets, you have to use this library data source trust, and you can put it. Let me just clear it so to make you better understand, right? Yeah. So library, then it was already if see. So first is given the data, right? Which data I shown you for here. And you could see that all the means of the data is similar, all the means of the y is similar, standard deviation of x is standard deviation of y is similar, and the correlation is also similar up to 2 points of the decimals, right? Clear? Then let me just, so I have shown this in front of you that we have presented the data here, and then using the ggplot, right, we can plot this here. So as moment I have plotted this here, you could see the, and we have put into the different colors, right, which can give you the different shapes. So I have only plotted this data which is presented here in the data source, doesn't, right, nothing else. And data source doesn't file has his data set. This is in front of you. Clear? Fine. If you need any specific things, you just please let me know. I will explain you to. Otherwise, I believe it's done from my side. Yeah.
Thank you, dear professor, for your nice presentation. Still, if at the end, I would like to ask from the participant, if you have any kind of question from your side, or you can easily ask by unmute your mic. Anyone, if you have question, you can easily unmute your mic.
Yes, Dr. Chan, do you need me to, do you want me to explain something else?
Yes, sir. Yes, sir.
Yeah. So as I said earlier, that nowadays writing a codes is not a big deal, right? We have multiple platforms available where you can generate the codes. There's no problem. Rather than interpretation is quite very important, right? So as I started my presentations with the examples of data source, that we have the same data points, but this different representations, different figures, different different feeling altogether. So once you are presenting somewhere the stars and another where you are presenting the data dinosaurs, right? You can understand the how different is interpretations of the data which is having the same value, surprising, right? And that's why the it's very very important to represent any data, any of the data first graphically, and then perhaps you can take it forwards with respect to the another statistical measure, maybe descriptive, inferential, etc., etc. And if you remember that day when we were talking about the correlations and regression, so I started with this, that first represents the data using the scatter plot, right? And then perhaps try to get any kind of another measures with respect to the another statistical tools, right? Okay, anyways, please feel free.
So I think there is no more question from the participant. Thank you, dear professor, for your nice presentation. And yeah, sir, there is one question in the chat box.
Right. So we have, we have discussed in the beginning that if we have the quantitative data or the categorical data. So for categorical data, we can represent it through the bars, through the pie chart, etc. But for the quantitative data, we have to present it through the maybe through the histogram, maybe through the stem and leaf plot. Yeah. Or the line chart, maybe. In case we are treating plants having different parameters, I have only seen bars about them, but how do we present better? Uh, I don't understand when you see the word better, what do you mean? Actually, since the different kind of parameters in the plants are the category, right? So category, as I said in the beginning, that has to be represented by the bars, and that's why whenever you see that, it is represented usually available in terms of the bars. Yeah, great, thank you. If you would like to make me more clear about your questions, perhaps would be better. Otherwise, fine if you understood. Thank you.
Thank you to all. And today's session on the data visualization and interpretation provided valuable insight into the principles of effective data visualization, the selection of appropriate graphs type of for different type data types and research questions, and the interpretation of graphical presentation in the biostatics is very helpful. And a heartfelt thanks to you, our professor, for sharing their expertise and enhancing our understanding of these critical topics. So once again, thank you, dear professor, to join us and to share your valuable thought and informative knowledge to all the participants. And thank you to all participants to be the part of this session. Tomorrow we will join at the same time. And now it is time to end the session. Thank you to all and good night.
Thank you, Dr. Chand, for your efforts which you are making from the last 9 days for the participants. And I understand that throughout the day you are working, and then
Yes.
again you are available in the nights. So I really appreciate from my side. Thank you. Thanks a lot.
Thank